Hello, Professor. My name is Bharatnandan Reddy Kallaru. Today, I'm going to explain patient management system, which is my final database management project. And here, the main objective of the patient management system is in today's critical healthcare environment. Patient record digitalization has completely changed the way where the healthcare is provided by enabling more efficient procedures, better patient outcomes, and more data security. Within healthcare facilities, patient data is stored, managed, and retrieved centrally with PMS, which is Patient Management System. The main purpose of Patient Management System is to revolutionize healthcare delivery by providing a comprehensive platform for managing the patient information and enhancing clinical workflows. By leveraging advanced data management techniques, this system enables healthcare professionals to access patient information seamlessly, leading to more informed decision making, accurate diagnosis, and personalized treatment plans. This efficiency not only improves the overall quality of care but also allows healthcare providers to focus more on patient interaction and clinical duties, ultimately enhancing the patient experience and satisfaction. The modules expected in this project are patient information management, appointment scheduling, clinical documentation, prescription management, billing and insurance, reporting and analytics. And coming to operational scenarios, the operational scenarios are appointment scheduling and patient check-in, which helps the system to streamline the appointment scheduling and patient check-in process. Patient details are recorded upon scheduling and available slots are viewed through this system. Appointment information is retrieved for smooth and transition to the clinical encounter. And next operational scenario is clinical encounter and medical record management, where healthcare provides access patient records and document findings within the system. Medical history diagnosis and the treatments are retrieved using unique identifiers. During this constellation, providers update records with current information. The system ensures accurate documentation and facilitates the scheduling, follow-up appointments, or referrals if needed. Prescription and management are followed up by care. This is other operational scenario where providers issue prescriptions electronically through this system. Medication details and dosage instructions are entered for accuracy. Prescriptions are transmitted to the patient's pharmacy for fulfillment. Post-visit follow-up care is supported with tools for monitoring progress. Integration with medical records enables providers to track patient response and not only to adjust treatment plans for necessary. There are some technical constraints, which is data volume scalability, where a potentially large volume of patients' data include medical records, appointments, and prescriptions. This constraint may arise concerning the scalability of database architecture to handle increasing the data loads efficiently. Next constraint is about data security and privacy, where ensuring the confidentiality, integrity, and availability of patient data, which is a huge paramount. Technical constraints may include implementing robust encryption mechanisms to protect system information both at rest and in transit. Additionally, access controls and authentication mechanisms must be enforced to restrict unauthorized access to patient records. Compliance with data privacy regulations such as HIPAA in the United States and GDPR in the European regions imposes technical constraints regarding data handling, storage, and access. Next constraint is about interoperability and integration, where healthcare systems often compromise multiple interconnected components such as electronic health records, billing systems, and laboratory information. This technical constraint may arise concerning interoperability and data exchange between the systems. Standardizing protocols such as HL7 for healthcare data exchange and API integration frameworks may need to facilitate seamless communication. Next, coming to tables which are created. I have been created 6 tables, which I'm gonna show in the SQL database. I have created 6 tables, which is insurance companies table, which shows the details of insurance companies. If I execute this query, it retrieves all the data of insurance companies in the same way. If I execute the next query, which is about patients, patients table, if I execute this, it's gonna show the patients table. And next thing is about the doctors table. If I execute this, it's gonna show the doctors table where the hospital resides and the city and the country. And next thing is about appointments. If I execute this, it's gonna show appointments tables details. And next table is medical records. If I execute this query, it's gonna show medical records table. And the next thing is prescriptions. So this is the prescriptions table. These are all 6 tables which I created. And next thing is coming back to my PPT. And I have been creating insert queries to insert data into the respective tables. I have been used insert insurance companies with insurance ID, insurance name, address, phone, and email. And next for the doctors table, I have used attributes of doctor's ID, first name, last name, specialization, and the respective things, with vice versa for all the 6 tables. And next inner joins, where it shows how many appointments, patients, all these things executed here. And I have been used insertion tables here to insert data. And next thing is the queries. These defaults and check constraints are to alter the tables which I created earlier. And this is the list of database queries. This is also included in the document along with the screenshots of the results. This is about fetching the data, the respective query. Like this, I have around 18 queries. I will execute some of them in the database. So if I execute this, it's gonna show the patient's details along with the insurance company names. If I execute the second query, it's gonna tell me how many appointments are there for the doctors. And if I execute the next query, this will show me the appointments which is available in the current date, which is today. And next one is this will show me how many doctors are available in New York. And this query helps me to say uh, which are with the patient's ID and the first name and last name. And next query will tell me total count of female and male patients. And next query helps me to say how many total appointments are there for a doctor. And next query is about patients first name, last name again from, but this time I have inner join with medical records and prescription. Previously, I have inner join with medical records and appointments. Here I did with prescriptions. This one with the appointments and the doctor's first name, last name, and the specialization. Oh, sorry. The patient's first and last name with the patient ID and the specialization in which category they need to get the treatment. And with this query, I gonna get what is the average appointment count for each patient. It's gonna be only one. It seems to be there is uh, no patient with a multiple problems. And this query helps me to the patient who is suffering with the cardiology. And next query is to execute the patients and the doctors. For John Doe, it is John Smith, and Jane Smith, it's going to be Emma Johnson, vice versa for everyone. And this is to execute about which medication is taken by John Doe. I mean, like, who is taking aspirin medication? Sorry. And next query is about appointment date, who is having appointment on particular date, which is April 25th. And next query is about appointment ID and the patient ID. Next query is again the first name, like the patients and doctors' names. This time I have inner join with appointments and the doctors' tables. And this is about retrieving the data of a patient who is going to the general hospital. It is only John Doe with Dr. John Smith. And coming to our last query, it's gonna help us about the appointment date of each patient between 2 and 6. Coming to the presentation, these are all the queries along with the screenshot results, which I have taken earlier. And coming to ER diagrams, we have 6 entities: insurance companies, patients, medical records, appointments, doctors, prescriptions. And coming to insurance companies, it is insurance ID with the primary key related to patients table, and the patient's table with the primary key as is patient ID, and the insurance ID is the foreign key, which relates to the insurance company's table, and the medical records with the record ID as primary key and patient ID as foreign key, which relates with patient's table, and prescriptions table with prescription ID as a primary key and relates to patient's table with patient ID as foreign key in prescriptions table, and appointments table with appointment ID as primary key and patient ID and doctor IDs as foreign keys in appointments table, which relates appointments table to patients table and the doctors table too. Doctors table is included with doctor ID as a primary key, which builds a relationship with appointments table as well as the patients table. And the prescriptions is already discussed with the prescription ID as primary key and patient ID as foreign key. And these are the tables created: insurance companies table, doctors table, patients table, appointments table, medical records table, prescriptions table, and so on. Relationships, and each relation to prescription is related to patients, and patients is related to medical records, insurance companies, appointments, and appointments is related to both patients and doctors. Doctors is related to appointments and internally related to the patients table. And insurance companies is a one-to-many relationship where it is, can have multiple patients, and insurance ID as primary key related to patient's ID, and patient's table is a many-to-one relationship, and each patient can also have multiple appointments, which is a one-to-many relationship. Each patient can have multiple records, one-to-many relationship again, and each patient can have multiple prescriptions, which is also one-to-many relationship. Doctors, where doctor can have multiple appointments, one-to-many relationship. Appointments, where each appointment belongs to one patient, which is a many one-to relationship. Here we have a different change in relationship, which is a many to one. And medical records, which is each medical record belongs to one patient, which is many to one relationship. And prescriptions, each prescription belongs to one patient, which is many to one relationship. And the conclusion of this project is the patient management system represents a comprehensive solution which is aimed to revolutionizing healthcare delivery by centralizing patient information and streamlining clinical workflows, which enhances the quality care and optimizing administrative process. And overall, the system not only improves efficiency and accuracy in healthcare operations, but also prioritizes patient care and satisfaction, making a significant advancement in the healthcare technology. Thank you.